Welcome to Multiview Sketching. We're going to go over this notes fairly quick because I think it's something more important that we actually put our hands to and draw in class than trying to watch a video for. While we still will try to do some in class, there are some videos underneath this one on the Learn page that'll help you and maybe help you understand how to do Multiview a little bit better if you do not get it after class today. So Multiview Sketching is how we show two or more dimensional views of a three-dimensional object. So we have an object, we make it, we want to send it off somebody to manufacture and mass produce a whole bunch of them. So we've got to give them multi-view drawings with dimensions and stuff. So we got to be able to draw it and look at a top, front, and right side view, which is kind of industry standard for us. So here's a multi-view drawing that is finished. We have the isometric view in the top right. We have the orthographic projection of the top, front, and right side. Top view is looking straight down on the top. Right side view is looking from this right side that's here. So we see these two cubes. We see this part that's there. So the two cubes and that part and that indentation. And then that front view, this long L that's there, along with that missing piece or that hidden line of that indentation. So we're going to draw this today. We're paying attention to left edge, right edge, match up, top, bottom, match up as we try to do stuff. Line here, line there, line here, line there. Line here, line there. Everything matches up, everything looks symmetric. We use grid paper so we don't have to worry about it as much. 3 dimensions, width, height, and depth. Width is side to side, height up and down, depth front to back. We'll talk about that as we look at the objects themselves. So here's the top, front, right. Top view has where it says top along with the slanted view. Right side view has where it says right along with that slant. That slant pushes forward and mashes there. It looks like more like a square or a rectangle. And then that front view, that long shape, that natural position that's there, it gives us the whole thing in the shape. This shape right here has uniform depth. Uniform depth from the front to right. If I was to cut it in half, I would still kind of have the same shape and the same drawing. So uniform depth there we'll learn later on. We only need to really only draw the front view for it. Isometric drawings go in the top corner here. They erase them from the actual picture to show you the top, front, right. Height dimension is both on the front and the right. Width, top and the front. Depth goes on the top and the right side that is there. Everything's lined up. Bottom, top, left, right. Technique they're going to use to make these drawings is more of the projection method. They're going to put a little box around it and then project those planes. Take 1, 2, 3, 4, 5, those different corner points, project them onto a plane and then trace around those. They're going to look at this puzzle cube piece. Front side view has one rectangle, square and a square, one rectangle, square and square. Notice there's no object line in the middle here. There's nothing cutting that in half. Right side view is one square, two squares, and then the long rectangle, one squares, two squares. That long rectangle, I'm thinking from the top, you have one square, two square, three squares, one square, two squares, three squares. We're going to worry about top, front, right, but you could look at the bottom. Look from the bottom, you've got 1, 2, 3 squares, and you have these two edges that you don't see. If you look from the left side view, you've got a long rectangle, a square, and a square, but again, you don't see this edge that's here, and you wouldn't see that edge that's in the middle that's there. And then the rear, look from the back. Look from the back, you've got a long rectangle and then that square off to the side. You wouldn't see this edge and you wouldn't see that edge. That's where those hidden lines come in for us. Sectional view, why do you pick the front? We went over this slide a couple days ago. Natural position and working through. One view, so the number of views that you need. So you can save yourself some work if you think about how many views you actually need. You only need one view if you've got uniform thickness. We'll show example of this in class, but you just got a base plate that's here. It's uniform thickness. We'll go through. So if you've got your notebook, your notebook's got uniform thickness to work through. So you only need one view with that. Two views means if two views are the same, you can eliminate one. So an example of this is that screw that is in the back of your chair. It's a circular piece with the screw that's coming through, so as you rotate a circle, everything's the same. Take a water bottle. As you rotate a water bottle around, the left and right side view, the front and the right side view are the same. It's the top when you look down at the bottom and see that cap, and then as you rotate that circle around, everything's the same, so we don't need to worry about two of them. That's why we've got the two views that are there. So sketching multi-view we'll do in class. We'll make sure we got those right before the end of the week, make sure we understand it. Top, front, right, they're going to go through quick. Kind of sketch there, show how they did it, do the construction lines, and the object lines are thicker. That's the biggest thing I'll be looking for this week, making sure those construction lines are thicker than those object lines. Drop in the hidden lines that match up with missing edges. Think about that. Think about what's there and what's not there. Here's some different examples of a nice top, front, and right view, different sketches from history. And then the last thing that we've got is, if you've got these different views, what do they have in common? So think about that. We'll talk about it in class tomorrow. Thanks.